I needed to make some gaskets out of EVA foam, and after hunting around the net for a bit about ways to cut it neatly, I came across a method by Wildcard using a Dremel with a 3.2mm router bit and a guide collar that you run around the template. After a bit of playing around with different ideas, I ended up with a 3D printed guide that screws onto the Dremel and runs around a 3D printed template. I'm going to show you how to make a template to use this guide that I developed. It's quite a bit of work for a one-off piece, but does give a very good result. It makes more sense if you're going to use the template multiple times. It makes future cuts quick and easy. Here's one I use regularly to cut a foam gasket. You're going to need some basic CAD knowledge. I'll be making it in Fusion 360, but most CAD packages should be able to do something similar. First, we'll start with our design. We'll call this one the blob. Step 1 is offset the edges inwards 1.2mm. This will give a little clearance between the cutting tool and the template. Step 2 is to offset the edges outwards 12mm. This is going to make our support rail, which gives the guide on the Dremel more support, makes it easy to keep it straight. You can get away without it, but in some parts of the design it's not needed, but it definitely makes the cutting operation easier. Next step is to offset the edge outwards about 22mm. The exact distance isn't that important, it will depend on your model, but a 10mm wide support rail is a good sort of width. The next step is to extrude your rails upwards 6mm. Now extrude your template up 3mm. Next, start a new sketch on the top face of your template and offset the outer edge in 3mm. Now you want to extrude the inner part of your template up 3mm with a 15-degree taper. Now we need to make pinholes to hold it down. Start a new sketch on the top of your template. Offset the edge inwards 4mm or so. Exact distance will depend on your design and you can play with it a bit. Now I need to drill a hole somewhere on the line you just made. You want a counterbore hole with a counterbore large enough to take the head of the pins you will use to pin it down. Here's a 3mm counterbore, 2mm deep, and a 1.2mm hole that doesn't extend all the way through, as you're going to clean up the holes with a drill at the end anyway. Now you want to run a pattern of holes along the offset line. The number and spacing is up to you, but you want a reasonable number. And fill in any missing sections or places that look like they may need an extra pinhole with some more holes. Now do the same with your support rails. And there you have it, one blob template. And here's just a look at the cross section so you can see exactly what it looks like. that's what you just made. And here's the template part with your tapered bit and a bit of a support rail. Now you want to save this as an STL, import it into your slicer and print it. If you turn ironing on for the top layers, you'll get a flatter surface to run over, but it significantly increases the print time. It's definitely worth it if you're going to use it multiple times though. And here is the finished blob template and supports. Now you need to take about a 1.2mm drill and drill through all the pinholes. Now we need to set up our Dremel. You want to set the depth of the bit so that it just cuts through your foam. Now we need to pin it down onto our foam. Use a piece of scrap foam or some cardboard thick enough to pin into as a backing. I'm using a piece of 10mm EVA foam here for the example, and some cardboard as a backing. It's a little bit small and the support rail hangs over the edge in a couple of places, but it should be fine. The limit of the router bit is about 12mm, so you can stack two pieces of 6mm foam on top of each other and cut both at once, no problem to get two identical pieces at the same time. Position the support so they're evenly spaced for the template, but it doesn't have to be perfect. For this template over here that has straight sections, I made some spacer blocks that make it quick and easy to set up. Use a tool such as a punch to push the pin heads down below the surface. It's important to note that the good cut edge will be to the left of the bit in the direction of travel. So for an outer edge, you'd be going anti-clockwise, and for an inner edge, you'd be traveling clockwise. Let's start cutting it out. Let's pop the template off and see what we've got. And there we have it, one not terribly bad 10mm thick blob. Seems to be roughly the same as the template. This system can be used to cut anything the router bit is capable of cutting, such as thin perspex or MDF. In this instance, you'd use double-sided tape to hold your template and guides down. And if you aren't going to use any foam, then you don't really need the pinholes. want your finished piece to have some double-sided tape on one or both sides, then I'd just apply the tape to it before cutting out, and you'll get a perfect cut edge on your tape. I hope this is some help to somebody.